Alright, extra practice problem, module 7, number 4. This is more along the theory line. So we have, they're giving us, okay, I'll read the problem. For the following situations, describe what will happen to centripetal force required to keep the object moving in a circle. So we know we're going to be dealing with centripetal force, so we can write that down. Fc, we're obviously going to be using the Fc equation here. Mass times velocity squared divided by radius. Okay? Sorry if that's cutting out a bit, but you can refer to it in your book. First situation, the mass doubles and the other variables are held constant. So our first equation looks something like this. And we wouldn't learn or figure out what does doubling the mass do to Fc. Now you may be wondering, like, what the heck, we just added a 2 to the m. How does that change anything? Yeah, don't worry, I'm going to explain here. So this might pop up on the test, it might not, I'm not sure, but in the event that it does, what I like to do, and this is a little trick, I'm going to try my best to explain it in a way that you can understand and replicate it. I like to try and substitute some numbers into all these variables. And what I do is I pick one number, usually a smaller one, or something that is divisible by a good number, such as 2 or 10, and then I plug it in for all the variables, and then I'll go and double it or triple it, depending on what the problem asks for, and see what the answer is. So, for the first step, we're going to take the first equation, and I'm going to plug in 2 for m times 2 squared divided by 2. Okay? If you were to work that out, 2 squared becomes 4, times 2 is 8, divided by 2 makes the answer 4. If you notice, these two cancel. Now this isn't always a situation, we don't have r, m, and v always equal to each other. This is just for theory purposes, to try and figure out what will happen in the event that they're all equal to each other, and we want to see what changes in Fc. So in this case, our answer is equal to 4. Okay? Now, let's take this equation. So we're going to have 2, and we're going to use the same variables. So 2 for m times 2 squared divided by 2. Now, if we were to work that out, we would see that 2 times 2 is 4, times 4 divided by 2, that's equal to 16 divided by 2, which is 8. Okay? Again, sorry if it's going downhill here, it's part of the deal. So now we got to compare these two numbers here. How are they similar? Well, we doubled the mass, and when we had a regular mass, it was 4. When we had a double mass, it was 8. So our number here doubled. And that is the centripetal force. So we can write down as our answer, when the mass doubles and the other variables are held constant, the centripetal force will double as well. Or, you don't even have to say as well, just say it'll double. Okay? You could even come in and use different numbers for the variables, and I'll do that in a later problem. This was fairly simple, so we don't need to do that. Next, they ask, the velocity is reduced by 4 times, and the other variables are held constant. So, our equation is going to look something like this. M stays the same, radius stays the same, but velocity is reduced by a factor of 4. That just means you divide it by 4. It's not reduced by 4 times, meaning that you subtract 4 from it. No. The times indicates multiplication, but the reduction is the opposite of multiplication, which is division. Okay, so we're going to find out what the difference is between this FC and this FC. So, if you were to look at this, use the information from the thing we just did. We doubled something on the top, and FC doubled. In this case, we're dividing something on the top by 4. So, what do you think will happen to FC? Will you see a 4-time reduction? That's a decent hypothesis. But we have the square here too, so maybe it's 4 squared. Let's find out. So again, we can use the number 2. In this case, I'm going to use the number 4, because if I were to use 2 here, it would be 2 over 4, which is 1/2, and I don't want to work with squaring fractions. So, to make it simpler, I'm just going to use 4 all around. So 4 times 4 squared divided by 4. That comes out to 16. And now, we make note of this number, and we go to this equation. Plug in 4 times 4 divided by 4 squared, all divided by 4. That is just equal to 4 times 1 squared. Again, divided by 4. 4 times 1 squared is just 4. Divided by 4 makes the whole answer 1. So, what's the difference between these two numbers here? You could say there's a 15 difference. So, when you're doing this, you gotta be sure to draw correct conclusions. If I were to say that when you divide velocity by 4, and you keep all the other variables the same, that your centrifugal force is reduced by 15. Just subtract 15 from it. That would be an incorrect conclusion. Why? I'm going to show you in a second. So let's say instead of 4, I used a bigger number. Let's say I made it 8. I can use my hand here. So we have 8, 8, and 8. Keep them all the same. 8 squared is 64 times 8. I gotta get my calculator here. It is 5.12 times 10 to the second divided by 8. Just comes back out to 64. And then again, you could cancel these out if you wanted to and just use 64. If you don't know how to do that, don't worry. I don't want to confuse you here. So 16 becomes 64. And then right here, before it was 16. Now, what about down here? Let's plug in our 8s. So 8 times 8 divided by 4 squared over 8. The reason I used 8 is because it's divisible by 4. If I were to use, say, 10, I would have a wacky fraction, 2 and 2/4 or something. Squaring that, major pain. But squaring 2, that's just a simple 4. 2 squared is 4. And so our answer will come out to 4. Before, it was 1. So now, what do 64 and 4 have in common? Well, they're both divisible by 4. But let's see how many times 64 or 4 goes into 64. So to do that, we divide 64 by 4. And we get 16. Now, you may be wondering, Eli, what the heck, why did you just randomly pick that? Okay, let's make it more simpler here. So our first idea was that you just subtract 15 from the number. But now we have 64 and 4. You have to subtract 60. That doesn't connect. what the heck? So you can set up a little equation solving for x. So when you set up this equation, what you're going to do is you're going to have the number you're comparing times x equals 64. And this is going to tell you how many times 4 goes into 64. So you divide both sides by 4, you get 16. Now, if we were to do the same thing with 1 times x equals 16, divide both sides by 1, we still get 16. So we see here that there's a connection. X equals 16. What is x? X is how many times you multiplied the answer down here, which was changing. So, how do we combine all this data into an answer? Look at the original question. When the velocity is reduced by 4 times and all the other variables are held constant, what happens to the centripetal force? So we held all the variables constant here. We got 64. We changed the velocity here. Keep the rest of the variables the same. This is like the control, the regular equation, and we're comparing it to a modified equation. It's like a science experiment almost. And we saw that our answer came out to 4. Then we did some checks again, and we concluded that 4 times 16 is equal to 64. Then when we ran through this again, we saw 1 times 16 is equal to 16. And this shows us that when you divide this by 4, divide the velocity by 4, or it's reduced by 4 times, your answer for centripetal force will be reduced by 16 times. I really hope this makes sense. And I can explain why it happens, because you're reducing this by 4, and since it's being squared, your answer is reduced by a total of 16 times. Because remember, we did the mass, we simply doubled it, and our centripetal force was doubled. In this case, we divided it by 4, and our centripetal force was divided by 4. But since we square this variable right here, our centripetal force is going to be divided by 4 squared, which is divided by 16. Okay, let me do the last one real quick. Hopefully this will clear it up if you have any confusion. I'm going to write the control equation back up. So, the radius increases by 10 times, the mass decreases by 3 times, and the velocity is held constant. Okay, so this is our modified equation. So what did they say here? Radius increases by 10 times, divided by 10 times the radius. And the mass decreases by 3 times. So whatever m is, we're dividing it by 3. Velocity is held constant. Okay? Now that we have it set up, let's plug in some numbers. How do you pick the numbers? Again, I already went over this. You want to pick something that can be divided nicely. You may be saying, well, Eli, what can divide by 3 nicely? You could do 3 itself. You could do 9. You could even do 300. In this case, I would recommend that you just pick, a nice 30. It's divisible by 3 and by 10. Okay, and that should give you some nice answers. There's no problem there. You won't have any funky squares. So, similar routine, 30 times 30 squared divided by 30. Hopefully you've noticed the pattern by now. These two cancel. And our answer is just 30 squared, or 900. Okay? For here, 30 divided by 3 times 30 squared divided by 10 times 30. That expands to 10 times 900 divided by 300. So, work that out on your calculators. 10 times 900 equals, and then answer divided by 300, and it comes out to exactly 3, if I'm correct. No, 30. So, come down here, write your answer as 30. Now what do we do? Remember, look at these two numbers here. What do they have in common? How many times does 30 go into 900? How the heck am I supposed to know? Don't worry, I taught you the equation for this. I don't expect you to know this either. Don't worry. So, come down here. X will equal something. In this case, we want to find out how many times does 30 go into 900. So we have 900. 30 over here. And let me erase the equal sign there. To find x, what do we do? Divide both sides by 30. 900 divided by 30 is equal to 30. And if you picked that up already from 30 squared, you may have been able to deduce it. That's fine. I'm just working through this the long way, no shortcuts or anything. So our answer here is 30. So, Eli, what are you saying here? Well, we've never done anything that's modified the radius on the bottom, so we don't know how that's supposed to alter the equation. But if I were to ask you, what does this 30 mean? We have two options here. Did it increase by 30 times, or did it decrease by 30 times? And the correct answer here is that it decreases. You may be asking, why does it decrease? Look at our control. If we had 30, everything is just by itself, our answer came out to 900. But when we started modifying stuff, our answer came out to 30. So this is way bigger than that. And so we can see that when we started modifying stuff, we reduced the mass by a factor of 3 and increased the radius by a factor of 10. That our answer was reduced by a total of 30 times. That means FC was divided by 30 if we were to compare these two. So you would write down reduced by 30 times as the answer for extra practice problem number 4C. Again, make sure you try and study up on this. I don't know if it'll be on the test, but this is something good to know. This is more along the lines of the theory, so I would expect that they'll try and throw something similar to this at you. So just be prepared to deal with it. I'd invest, maybe 10-15 minutes making sure you have a complete understanding. Let me know if anything is unclear. If it's just a bunch of numbers and letters and you have no idea what's going on, that's not good. You gotta be able to understand this stuff. You can forget it later, when you're done with high school, but if you want a good grade, you gotta pay attention now. Alright, have a good day.